Hello and welcome back. In this tutorial, we will learn to design this Learning and Development Insights dashboard in Microsoft Excel. This interactive dashboard is specifically designed for HR professionals, training coordinators, and department heads seeking insights into training metrics across the organization. It may also be used by training institutes such as schools and colleges, with some small modifications. So, what makes this dashboard stand out? First, VBA UserForm for data entry. The primary innovation is the utilization of VBA UserForm for input data. No more manual data entry. Once the dashboard is set up, simply click on Add New Record, and a comprehensive user form appears, streamlining the data entry process and eliminating errors. For instance, take a look at the training records. We currently have 34 training sessions logged. Similarly, in the trainee record, we can track which trainee attended which session. Let's demonstrate adding a new record in real time. Click on Add New Record. Select the training topic. Name of the trainer. Enter training hours, then number of trainees. And check the box indicating the trainees who attended the training. Lastly, click OK. Just like that, our 35th record pops into both tables. Once the data is in, clicking on the Refresh All button updates the dashboard instantaneously. Second, use of Power Pivot to link the tables. As we observed, our tables are floating independently. This is where Power Pivot comes into play. Let's open the Power Pivot. As we can see in Power Pivot, the tables are interlinked, offering a simple way to link and analyze multiple datasets without getting tangled in complicated formulas. Third, Get Pivot with Power Pivot. This combination of Get Pivot and Power Pivot ensures accuracy, as well as efficiency in data analysis. If you are new to VBA, UserForm, Power Pivot, or Get Pivot, don't worry. If you follow the steps shown in this tutorial, you will be able to design your own complete dashboard even if you are not familiar with any of them. Also, if you prefer not to use VBA or UserForms for this dashboard, that's perfectly fine. At the end of this complete dashboard tutorial, I'll guide you through setting it up using manual data entry methods, allowing you to design the entire dashboard without writing a single line of VBA code. Now let's take a closer look at the dashboard visuals and functionality. Starting at the top, here you can quickly glance at the total number of training sessions conducted, the cumulative number of hours devoted to these sessions, and the total number of hours clocked by trainees. Moving on, we have insights into the top performers. Find out who the top trainer is, what the most sought-after training topic is, and who the most eager trainee is. This bar chart illustrates trainers' performance. And this one, the impact of the training topics. This switch lets you view the total number of hours delivered or trainees mentored for both trainers' performance and training topic impact. Training is a continuous process. In this monthly trend chart, total training hours are displayed month by month, showing consistent efforts all year. Different departments have different needs. In this chart, we can see how close each department is to reaching its training goals. In this pie chart, trainees are distributed based on their target achievements, and we can see where most of our trainees are standing. A number of trainees achieve the target, a number of trainees are close to achieving the target, and a number of trainees are far from achieving the target. This percentage distribution can be further categorized or changed. I have kept greater than 100%, between 100 to 80%, and less than 80%. With the percentage achievement employee bar chart, you can overview the achievements of 10 trainees at a glance, and you can scroll through the list of other trainees to explore their individual achievements. The bar color changes automatically to red, yellow, and green based on the percentage achievement, considering the same distribution as above. The departmental analysis tree map provides a broader perspective. Simply toggle between total hours and average hours per employee for each department. Last, but certainly not least, the interactive slices. Filter data based on department, trainer, topic, or month. With just a click, customize the dashboard to show exactly what you want to see. Alright, we will design this complete dashboard in the following steps. Having covered the first step, introduction and dashboard overview, let us move on to the second step, preparation and overview of input data sheets. As we begin to explore the input data sheets, 3 significant steps must be taken in order to ensure that our dashboard functions as intended. First, file format. Ensure your input data sheet is saved in the .xlsm format. This is essential as it's a VBA-enabled worksheet, and we'll be making use of VBA functionalities. Second, Developer tab visibility. Check if the Developer tab is visible on your ribbon. Third, activation of Power Pivot. Ensure the Power Pivot feature is activated. If the Developer tab or Power Pivot isn't enabled, here's how to do it. Simply right-click on any tab and select Customize the ribbon. This action will bring up the Excel options window. For the Developer tab, just check the box next to Developer. For the Power Pivot, head to Add-ins. In the Manage drop-down, select COM Add-ins and hit Go. Ensure you've checked the box next to Microsoft Office Power Pivot for Excel. Then click OK, and you are all set. We will now take a brief look at the input data sheets. We start with master data, which consists of the table employee database, which contains the columns employee ID, employee name, department, and target hours for each employee. Next, we have the trainer table, which initially displays only the names of trainers. We will populate the following columns during the analysis of the data. In the following tables, you will find a list of training topics, departments, and months. The vacant columns in these tables will also be filled in during the data analysis. On the second sheet, titled Trainer Records, we currently have only headers. As we proceed, we will populate the data via the VBA UserForm. Third, the trainee records sheet follows a similar pattern, with only headers in place for the moment, and data will be populated using the VBA UserForm. There is a link to download this file in the description of the video. You can download it and follow along. Alright, let's move to step 3, designing VBA UserForm. You might be wondering, why a UserForm? Why not simply input data directly into our Excel sheet? The answer is simplicity and control. With a UserForm, we streamline data entry. A UserForm offers a more structured and intuitive interface, ensuring users input data correctly and consistently. It feels more like a digital form than a sprawling spreadsheet. Now, let's dive into creating our UserForm. First, open the VBA editor by selecting the Developer tab, then Visual Basic. Or just hit Alt plus F11 for a quick shortcut. Welcome to the VBA editor. To your left is the Project Explorer showing all open workbooks. As we can see, there are 2 Excel sheets currently open. One is our active project and the other is a demo dashboard, which already has a UserForm for reference. This center area is our workspace for coding. To the right, you have the Properties window detailing attributes of selected items. Feel free to rearrange it to your liking. Let's shift it over to the right for now. Alright, to kickstart our user form, right-click on our workbook in the Project Explorer. Hover over Insert and click on User Form. Here, a blank canvas appears. This is where our interactive elements will reside. Additionally, a toolbox will pop up, holding all the potential elements we can add to our user form. To preview the current user form, hit the Run button. As it is blank for now, this is how it appears on the screen. Now that our user form has been created, let us update its properties. We'll assign a name, adjust its size, and pick a pleasant background color. Let's copy the same user form name from the demo user form. Here, let's change the caption. I used this color from the palette for the background, and we will use it here as well. If you wish, you can select your own color, or you can customize it. We will now adjust the width and height of the user form. Let's change it in a categorized mode. By switching between alphabetic and categorized modes, you'll notice the properties remain the same. The key difference is alphabetic mode lists them alphabetically, while categorized mode groups them by function. Now it's time to add some elements. Let's see what elements we need to add from the toolbox. These are the labels, these are the text boxes, these are the combo boxes, this is the list box, and these are the command buttons. Let's add them to our user form one by one. Before that, if you close the toolbox or it is not visible, let's see how to show it. Just click on the view and select Toolbox, it will be visible. Let's begin by adding our first label. Click on the Label option to insert it. This gives us flexibility to modify various properties like its caption, color, font alignment, dimensions, and more. Let's take a quick look to see the changes. Okay, to save time, I'll copy the remaining labels from the demo user form. You can add them as we did. Next, add a text box for the training date. Adjust its background color and other properties as needed. For consistency, I'll use the background color that's been applied to text boxes, combo boxes, and list boxes in the demo user form. Now, add a combo box for the training topic. Fine-tune its properties to match the design. Simply duplicate this combo box for the trainer's name field. Similarly, replicate the text box for both training hours and trainee count. For our list of employees, we'll insert a list box. Next, we'll add a cancel command button. Customize it with a white font and red background. You can open the font property window with a click and change its attributes like type, style, and size. We can change the other properties, but to speed up things, let's delete it, and copy the cancel, clear, and OK buttons from the demo user form. I'll also replicate these labels to our user form. Since I've borrowed some elements from the demo, let's briefly review their properties to ensure you can recreate the same look in your design. With a few elements aligned, our user form is complete. Let's hit Run to preview it. Looks great. But we are not done yet. We need to populate our user form with data and make these buttons functional. Likewise, this box should contain the date. These combo boxes should have the training topic and trainers in the drop-down list, and this list box should display the complete list of employees with their ID, name, and department. Furthermore, we will define a specific action or event for each command button. For example, cancel should unload the user form, clear should empty the user form when we select anything, and OK will take the input data and write it to Excel. That's a task for our next step, coding for the user form. So, let's dive in. Before we jump into the coding specifics, it's best to practice that, renaming your Excel sheets. A clear, logical naming convention will save you a lot of confusion later. If you look closely here, you'll notice it says Sheet 1 Master Data. What does this notation mean? Master data, within the brackets, represents the actual name you've assigned to the sheet within the Excel workbook interface. On the other hand, Sheet 1 is the default code name that Excel assigns to worksheets. This code name is a unique identifier used in VBA to reference that particular sheet, regardless of its name assigned in the Excel workbook. As an example, you'll notice that our workbook currently houses 3 sheets. Let's quickly switch back to Excel to see this in action. You can either click on this icon here, or use the shortcut Alt plus F11. As we navigate back, you'll observe those 3 sheets named on the tabs. Switching back to the VBA editor, you'll also see these sheets represented with their respective code names. To put this into perspective, instead of working with a generic and potentially confusing Sheet 1, renaming it to something descriptive like Master Data in the VBA environment will make your coding tasks smoother and your script more intuitive. Let's rename these sheets accordingly, as we did for the demo sheet. Moreover, when naming UserForm controls, precision is crucial. For example, instead of a generic text box 1, a name like text_training date immediately lets you know its purpose. Let's copy the names from demo UserForm. For clarity, I've prefixed text boxes, combo boxes, and list boxes with text_, CMB_, and LST_, respectively. This aids in quick identification. As we borrowed some elements from the demo, they are already renamed. Furthermore, we do not need to rename the labels since they will not be used in coding. However, it would be better if you renamed them as well. To begin coding, right-click the user form name, or anywhere within the user form and select View Coding. Or simply double-click any vacant space therein. It'll bring up the code window specific to that user form. For now, we'll clear this section. Now, another best practice when working in VBA, always start with Option Explicit at the top of your module. This small step forces you to declare all your variables, reducing errors and making your code cleaner and more efficient. If you want to ensure Option Explicit appears by default in all new modules, just go to Tools, then Options, and check the box for Require Variable Declaration. Now, let's begin with the initialization code. This code runs every time our user form is launched. To kickstart, select User Form from this first drop-down and choose Initialize from the second one. Alternatively, type out private sub-userform_initialize directly. Let's scrap this first entry for the user form click. Since our text boxes in the user form are prefixed with text underscore, you can start typing that, and then, here's a trick, you don't need to finish typing it. Simply press Alt plus space bar. This key combination triggers IntelliSense in the VBA editor, which will offer up suggestions based on what you've begun typing. As you can see in the suggested list, the first text box corresponds to the number of trainees. Let's select it. Now, type .value. This .value property is an integral part of VBA when dealing with controls like text boxes, combo boxes, etc. It essentially captures the data or information the user enters. By typing equals double quote, we are making sure that the text box is cleared out. This ensures the text box is always empty when the form loads. Repeat the process for the training hours text box, and for the combo boxes for the trainer's name and the training topic. Next, for the training date text box, instead of the user manually entering the training date every time, we want the text box to automatically display today's date by default. However, users can modify it if necessary. Now here, instead of .value, we will use .text. The reason is that both properties deal with content in a control, but .text is more about real-time, transient content, while .value represents finalized, committed content. Next, type an equal sign followed by the now function. We will now empty any pre-existing trainee selection list data from the list box. By including this line, we ensure that the list starts empty and is cleared. Running this code, you'll notice the training date shows both the date and time. But we want only the date in a DDMYYYY format. This brings us to the format function. Let's add it to the code. Let us check it one more time, and it appears to be formatted properly. In our code, we'll use this date format several times. So, instead of repeatedly hard-coding the date format in our code, let's define a constant. This means setting a value just once at the beginning of our module, making our code more readable, and reducing potential errors. At the start, after option explicit, let's add it. The private keyword ensures this constant is only accessible within this module. Const denotes that it's a constant, a value that won't change as our code runs. We've named our constant date_format, which is per naming conventions. As string denotes that our constant holds a text value, and it will be in this format. Now, in the UserForm initialize subroutine, replace the date format with the constant we defined. This way, if you ever need to change the format across the entire module, you only have to change it once at the top, saving time and reducing potential errors. Alright, let's proceed with fetching data for the combo boxes. When you wish to populate a combo box with data from a range, you'd typically utilize the .list property of that combo box. This allows us to set a list of items for the user to select from. Start by typing the name of the combo box associated with the training topic. Now, append .list to it since we aim to populate its list. Next, we will assign it to a range within the Excel worksheet. Type equal to range, open parentheses, and inside the double code, we can specify the range. Instead of write the range name manually, we'll copy it from the Excel workbook to avoid any typos. For now, let's keep it blank and conclude with .value. Now, let's switch back to the Excel window. Navigate to the tab where the table is, and you'll find the table named TBL_trainer. Copy this name. Hop back into the VBA editor. Paste the name within the double quotes we left empty earlier. Repeat the exact same steps for the trainer name combo box, and ensure you pick the correct table name for it. By running the code, we can see the training topics and trainer names in the drop-down. Similarly, we are loading the list box with data from the Excel table named Employee Database. Now, if you preview the user form, you'll notice our list box displays only one column. We need it to display 3. Let's fix that. We will use the with statement instead of repeatedly repeating the list box name. Then type .column count equals 3. And we can end with statement. After this, if you run it quickly, you'll indeed see 3 columns, but they aren't aligned properly. Let's adjust their widths. For this, we'll add another condition within the with statement for the column widths. This line decides the width of each of those 3 columns. The first column is 50 units wide, the second is 80, and the third is 90. Alright, now the list box looks organized. However, there's one final touch needed. On loading the user form, the cursor defaults to the training date text box. For a more intuitive user experience, we want the cursor to begin in the training topic combo box. Let's fix it using set focus. That's it. The user form initialization is now optimized, making it user-friendly and intuitive. Give it a run and see how smoothly it operates. Moving forward, we need to define the actions that take place when you click those command buttons, Cancel, Clear, and OK. Let's begin with the Cancel button. The idea is simple: if someone clicks Cancel, we want to close or unload the user form. To set this action, double-click the Cancel button. This will take us directly to the code window specific to this button. Here, all you need to type is Unload Me. The word Me in VBA refers to the object in the current context. Since we are coding within the user form, Me signifies the user form itself. So, Unload Me translates to close the current user form. Next, the Clear button. The goal here is to reset all the controls in the user form, essentially bringing it back to its initial state. Now, since we've already written the initialization code for the user form, which sets everything to its default state, we can simply call that initialization again. Type in call userform_initialize. This ensures that whenever the Clear button is clicked, the user form will reset. Let's test it out. Let's make some selections and enter some data. And then click Clear. The form restores to its default state. And if you click Cancel, the user form will close. Alright, let's get started with our OK button click action. Before we dive in, let's organize our code a bit. Dragging this initialization code to the top, so that we can write OK click seamlessly and without interruption. To make it easier to see the code, let's add some space below. When a user clicks the OK button, we want to do 3 main things. First, we'll check if all the inputs are valid. For example, is the entered date actually a date? Did they select a training topic? and so on. If not, we'll prompt the user with a message letting them know what needs to be fixed. Next, if all the fields are validated, we'll then add the data into the Excel tables. And finally, we'll return to the dashboard and close the user form. It may seem logical that all these actions can be incorporated into one procedure, but that can be confusing and difficult to debug in the future. Instead, we will break it down into separate functions and subroutines. Let's begin with the Validate Inputs function. Here, we are using Validate Inputs as a function because after checking the inputs, it will tell us if they are valid by returning true or false. That's why we declare it as Boolean. Let's write first the date validation logic. Here, isDate is a function, and we are checking if the value entered in the training date text box is recognizable as a date by VBA. If it's not a date, we want to alert the user about the error. This is where the message box function comes into play. It's used to display messages to the user. When you type the MSG box, you'll notice its syntax. The first argument, prompt. This is the main message you want to convey. Let's type the message to inform the user that their date entry is invalid and guide them on how to resolve the issue. VBA also uses the AND operator for concatenation and joining strings like Excel. In our message, we are joining 3 strings. The second argument determines the icon and behavior of the message box. For instance, VB critical will show a critical icon, giving the message box a sense of urgency. You can select any of these. Next, the title of the message box. Let's give it a title as training date to make it clear which input the message is about. Once the user sees the error message, we want them to correct it easily. So, we shift the focus back to the training date text box. If an error is found, the exit function command ensures we leave the validation function immediately without proceeding further. Finally, the end if wraps up our conditional check. Once the date passes our validation checks, this line will confirm that the date displays in the specific format we defined earlier. Now, to test our date validation, we need to integrate this code within the OK button's click event. So, type if not validate inputs then exit sub. And run the form. Let's deliberately enter an invalid date, and click OK. Notice the message box that pops up. That's the VB critical icon we designated earlier, and the title atop the message box is what we assigned. With our date validation successful, let's expand our validation checks to other inputs. Next, we'll validate the training topic combo box. This time, let's choose the VB information icon for our message box. When coding, don't forget to indent for better readability. For that, we can click here, or use the Tab key. Run the form again, but this time, leave the training topic combo box unselected and click OK. The resulting message displays, and this is the VB information icon. We will now duplicate the validation check for trainer name and adjust as necessary. Let's copy the same for training hours. For training hours, our validation requires an extra layer. Not only do we want to verify that the field isn't blank, but we also need to ensure the entered value is numeric. Let's extend our code to incorporate this dual validation. We are about to introduce another level of validation dedicated to verifying the number of trainees. We are aiming to ensure that the number of trainees a user manually enters into a text box matches the number of trainees they select from a list. So, before diving into the code, let's understand how we will do that. First, we will traverse each item in the list box to determine if it's selected or not. Second, as we navigate through each item, we will maintain a running tally of the selected trainees. This will give us a cumulative count of all the trainees chosen from the list box. And post the counting process, we will then compare this tally with the count the user manually entered into the text box. In terms of coding, this approach requires the declaration of two specific variables. The first variable will be responsible for iterating through each item in the list box, essentially acting as our loop counter. The second variable will serve as our accumulator, incrementing each time we identify a selected trainee. Taking this into account, let's move on to the code. Let's start by defining these two variables. Next comes the with statement. Within this with block, we'll use a for loop to iterate over every item in the list box. It repeats a set of actions a specific number of times. Let's understand this line. We begin with I set to 0 and loop until I reaches 1 less than the total number of items in our list box. But, why do we start with I equals 0 instead of 1? This is because VBA, like many programming languages, starts counting from 0. So, if we have 10 items, they are numbered 0 through 9. Here, the .list count gives us the total count of items, but since we start from 0, we subtract 1 to get the last index. Now, as we iterate over each item, we want to check if an item is selected. This is done using .selected I equals true. Essentially, for every I, which represents an index in the list box, .selected I will be true if the item at that index is selected and false otherwise. Here, I have deliberately left out the dot before the word selected in order to enable us to capture it during the debugging process. You can add dot here while writing it. If an item is selected, it increments the trainee count by 1. If you are still unclear about it, we will go through each line one by one in the debugging process. However, before we do that, let's complete this code first. Once we've iterated over all items, we exit the with block and move to the comparison. If the number entered into number of trainees doesn't match trainee count, a message box popped up. Let's complete the code for this as we did earlier. Lastly, if no validation issues are found, the function validate inputs is set to true, indicating that our validation checks have passed. Okay, the input validation code has been completed. Let's test it. It will display the message if our selection does not match. Now that our code has been finalized, we need to ensure that it is working as intended. This process is what we refer to as debugging. Debugging isn't just about identifying errors, but also about understanding how our code operates in real time. Furthermore, we will observe how the code works in practice, and closely monitor the changes in variable values. You'll notice the employee database is quite large. Debugging with such a vast dataset can be time-consuming. To make our session efficient, we are going to work with a smaller subset. Let's make some modifications to the initialization code. To temporarily disable the existing code, we'll convert it into a comment. For that, simply click on the comment block option. Now, let's copy the code for list box and replace employee database table with the trainer names, which is significantly smaller in size. Let's run the modified code. As expected, our list box now displays only 8 trainers. Next, we'll observe how our variables I and trainee count operate throughout our validation process. To step through the code line by line, either click on Step Into or use the F8 key shortcut. You'll notice the currently active line gets highlighted in yellow. Before diving deeper into the debugging, we'll open the Locals window. It's a handy tool that provides real-time data on our variables. To access it, go to the View tab and click on Locals window, which you can see now on the screen at right. Let's continue with the debugging. Now, we are at the end of UserForm initialization. So, if we now click further, it will open the form. Let's feel it out. Here we have selected 4 trainers out of 8. Clicking OK activates the code tied to the OK button. We are now diving into the Validate Inputs function. Entering this function displays our variables along with their current values and data types in the Locals window. Now we entered into the trainee count section. If you hover on the I or trainee count, it will also show the values of them, which is currently 0. Let's continue debugging. As we completed one loop, the I value changed to 1, but the trainee count remained 0 since the first list box was not selected. However, as we progress, an error pops up. Clicking Debug will take us to the exact line that is causing the problem. Here, we have not added dot before selected, so let's do so and proceed. At the end of the loop, I equals 8, representing the total number of trainers, and trainee count equals 4, reflecting our selection. After this, the loop ends, and the code continues. The counts align, which means our validation works. Through this step-by-step walkthrough, you have seen the code in action behind the scenes. However, we haven't yet coded the functionality of adding records to Excel. That's our next step, crafting the code for Add Records. For now, let's stop debugging and move on to the next coding for adding records. Close the local window since it's no longer needed. What we are aiming to accomplish here is the automatic population of both trainer and trainee records into the Excel sheet. Let's understand how we will do that. For trainer records, we need to identify which is the next available row to prevent overwriting of any existing data. To achieve this, we'll declare a variable that will guide us to the exact next available row for input. Similarly, for record keeping, we need each trainer's record to have its unique identifier. Therefore, we'll have a separate variable which will give us the next available index number, allowing every record to be unique and organized. For the trainee records, we'll reuse the same two variables for trainee, but these variables would help us add only first the record in the list, and we will have multiple trainees selected. Therefore, to go through each selected trainee, we'll need an additional variable, which will act as our loop counter. Remember how we used a similar approach during the validation of the trainee count. Alright, let's deep dive into the code now. Let's begin by declaring the procedure private sub add records. Let's define the 5 variables we discussed. First, let's insert the trainer record into the Excel sheet. To begin, we must ensure we are working within the right worksheet. Input the command trainerrecords.activate. This ensures we are operating within the designated trainer records sheet, setting the stage for the data entry to follow. To pinpoint where our new data should go, we have to identify the next empty row. For this, type this line. But what does this line do? The COUNT_A function here counts all filled cells in column A. Adding +1 to it ensures we target the very next empty cell. As an example, our sheet currently only has headers. The function will indicate a count of 1. By adding +1, it guides us to the second row, ready for the new data. Every record needs a unique identifier. For this, type this line. Here, the max function fetches the highest current value from column A. As an example, for our first entry, since there are no existing records, the maximum value will be 0. When we add +1, it means we are assigning an identifier of 1 to our first record. As we keep adding more, this value will increment automatically, ensuring each record has its distinct ID. Now, let's detail the actual data entry command. Here, the range indicates the location within Excel sheet where we want our data. A is our column, and trainer row is the computed row from the previous function. This points to the exact cell we are targeting. And what we are going to input is the unique identifier or trainer max index. For the remaining columns, replicate this line and modify as necessary for the B to E columns. And there you have it. With these steps, we can successfully populate the trainer record in the Excel database. To begin with adding trainee records, let's leverage some lines of code we've already discussed. Now, let's reuse and modify some code snippets we've covered in earlier sections. Remember the loop we used to validate and count trainees? We can adopt the same structure here, but this time, instead of merely counting, we'll populate our Excel sheet with data. Let's replicate the line of code used for populate the trainer records and modify it for the trainee record sheet columns. Here, we are pulling data from the trainee selection list box. The method .list is used to retrieve data from list boxes. Here, the I refers to the selection count, and 0 refers to the first column of the list box. 1 for the second column, and 2 for the third column. Lastly, we increment trainee row and trainee max index by 1. This is to ensure that the next time we loop through, we are pointing to the correct Excel row and providing a new unique identifier for the next trainee. Alright, we've successfully set up a system that records each selected trainee's data into the Excel sheet. We can test the code, but before that, we have two important tasks to tackle. First, integrate the Add Records code into the OK button click event. Second, revert the list box code where we replace the employee database with the trainer's name. Delete this line. Select this code and click Uncomment block. With these changes in place, let's run the user form and fill in the details. Upon clicking OK, you'll notice the data populates in the sheet, but the user form remains open. Ideally, once the data is recorded, we'd want the user form to close automatically. To achieve this, navigate back to the code. After the Add Records line, simply type Unload Me. This ensures that after populating the data, the user form is unloaded or closed. Let's test it. Currently, we've been launching the user form directly from the VBA editor. To provide a more user-friendly experience, we will add a command button directly on the sheet, which will allow users to launch the user form seamlessly. First, let's add a new sheet titled Dashboard. Here, we'll design our complete dashboard, which will also feature a button to launch the user form. To add the button, go to the Developer tab, select Insert, select the command button under the ActiveX control group. Right-click on the button to access its properties. Here, let's update its name and caption accordingly. Double-clicking on the button will take you to its code. Let's first change the Sheet 1 name to Dashboard, as we did at the beginning for the other sheets. Now, input this line to assign the function of showing the user form. Let's copy this button for the Refresh All button and update its properties. Refresh All, which refreshes all data connections in the workbook. We can now test the button, but before doing so, make sure to exit the design mode. You can see that it added the records, but after that, we want it to return to the dashboard. Let's update the code to achieve this. Alright, the code is completed. Now, let's observe the code execution using the Step into Debugging feature to see what's happening behind the scenes. In order to see changes in Excel and VBA in real time, I have arranged the windows side by side. Let's begin. After initialization, it will launch the user form. Let's update it. On clicking OK, it will start the OK click event. Then validate input function. Here, the code will evaluate each item in the list box, and this will take time. As we can see, the number of trainees matches the selection, so we can bypass this portion to save time. To skip it, click on Step Out, and this brings us directly to Add Records. Now watch closely. Currently, we are at the master data sheet. When this line executes, it switches to the trainer record sheet. In this sheet, we have 3 existing records, so we can see that trainee max index is 4 and trainee row is 5. It has started populating records with precision. Next, we have entered into the trainee records sheet. As the first record is not selected, these lines will not be executed and will jump to end if. In the next I, that is the second record, it will start adding the records. In the list box, the rest of the boxes are not selected, so let's skip them. Afterwards, it will return to the dashboard and unload the user form. Alright, we will continue with the remaining steps in the next tutorial. If you find the video helpful, don't forget to give it a thumbs up and consider subscribing to the channel if you haven't already. See you in the next tutorial.